So here we're exploring the change of coordinates matrix. So we want to let matrix P sub B be defined by the column vectors B sub 1 through B sub n, and we'll let the coordinates of vector B relative to the basis B be the column vector of our coefficients or our weights. And this, of course, is where B, defined as the set of vectors B sub 1 through B sub n, is the basis. So this matrix here, this P sub B, is what we call the change of coordinates matrix. So we can use this to rewrite that vector equation. So we know by definition of the coordinates of vector x relative to b that these scalars come from the vector equation c sub 1 times vector b sub 1 plus c sub 2 times vector b sub 2 plus all the way to c sub n times vector b sub n. And we know that this vector equation is equivalent to the matrix equation, where we have the matrix with column vectors b sub 1, b sub 2, all the way to b sub n, multiplied by the column vector with components c sub 1, c sub 2, all the way to c sub n. And so these are two equivalent forms. And now using our new notation here, we can say that this is also equivalent to the change of coordinates matrix P sub B multiplied by the vector x, or the coordinates of vector x, relative to b. So these are all three equivalent forms to write our vector x here. And in particular, we want to use this new notation to establish an alternative way to find the coordinates of vector x relative to b. So starting with this vector equation here, we want to left-hand multiply by the inverse of this matrix P sub B. So again, we have vector x, and then making sure we give ourselves enough room here. We have the change of coordinates matrix multiplied by the coordinates of vector x relative to b. And we are going to left-hand multiply both sides here by the inverse of matrix P sub B. So by the distributive property, we can rewrite the right-hand side as follows. We can think of this as the inverse of matrix P sub B multiplied by matrix P sub B multiplied by the coordinates vector. And we know by the properties of inverse matrices that this leaves us with the identity matrix multiplied by the coordinates vector. And again, by properties of matrices here, we know that anything multiplied by the identity matrix, we're left with that anything. So we are just left here with the coordinates vector. So this is giving us an alternative way to find the coordinates of vector x relative to basis b. So real cute, quick example here. We want to find the change of coordinates matrix for this given basis b. And so we have two vectors in our basis, b sub 1, b sub 2. So using the definition, we can say that one possible change of coordinates matrix would be defined as vectors b sub 1, or column vectors b sub 1, b sub 2. And so we are left with the matrix 1, 2, 3, 4. And that's it. Woohoo! I also want you to note that we could define the change of coordinates matrix P sub B as vector B sub 2, B sub 1. This is fine as well. It all depends on how you label things.